Everyone, let's quickly solve this differential equation using two methods. Okay, x raised to the power 4 plus y raised to the power 4 dx minus xy cubed dy equal to 0. Now, the first method we are going to be using is the homogeneous differential equation method. First of all, we can see that the equation is homogeneous. How do I know that an equation is homogeneous? When f of lambda x and the function of lambda x lambda y is equal to lambda raised to power n times f of xy. Okay, so what that means is replacing x with lambda x and replacing y with lambda y, we are going to end up getting lambda raised to power n f xy. Now, if we do that quickly, look at this equation. Now, let's replace x with lambda x. We're going to get lambda raised to the power 4, x raised to the power 4, plus replace y with lambda y. We are going to get lambda 4, y raised to the power 4. Now, all the x, then minus x is lambda x, y is y cube, means lambda cube y raised to the power 3, okay? Then dy. So you'll notice that lambda raised to the power 4 is common, so we can factorize lambda raised to the power 4, and we are going to get x4 plus y4 dx, then minus xy cube dy, which is exactly what we have here. So we use the homogeneous method, can do this. So first of all, we make dy dx the square root of formula. Of course, it starts by making this crossing this the other side of the equation, and we will get lambda x raised to the power 4, y raised to the power 4 dx is going to be equal to xy cubed dy. Okay, so if we make dy dx the square root of formula, we are going to get that dy dx is x raised to the power 4 plus y raised to the power 4 all over xy cubed. At this point now, we can divide through by x raised to the power 4. Remember, in homogeneous differential equation, you must represent everything in terms of y over x. Okay, so if we do that, to achieve that here, we divide through by y raised to the power x raised to the power 4, and if we do that, that's how we go here to be 1 plus y over x all raised to the power 4. Let's do that quickly. X raised to the power 4 over x raised to the power 4, like we know, is 1. Then plus y raised to the power 4 over x raised to the power 4. Then everything divided by xy cubed over x raised to the power 4. So if we do that, you see that here cancels here to be 1. Then y raised to the power 4 over x raised to the power 4 will give us y over x all raised to the power 4. And divided by here, x will cancel one of the x here to be 3. So you have y cubed over s cubed, which means y over x all raised to the power 3. Okay, so that is the reason why we got this. And according to the homogeneous equation, you represent y over x with v. So that gives us 1 plus v raised to the power 4 over v raised to the power 3, then which is equal to 1 over v raised to the power 3 plus v. Don't forget that 1 plus v raised to the power 4 all over v3 means 1 over v cubed plus v raised to the power 4 over v cubed. So that is going to give us 1 over v cubed plus v raised to the power 4 over v cubed now is going to give us v. Okay, so that's exactly how we got this, and that is equal to f of v, which is the function of v. Now, our solution of homogeneous equation is this. That is the x over x minus the v over f of v minus v equal to 0. So here we just need to substitute the value for f of v, which is 1 over v cubed plus v. Okay, then minus v equal to 0. So you can see here that v minus v is gone. So we are going to be left with the x over x minus the v, okay, all over 1 over v3 equal to 0. which when you divide, you are going to get the x over x minus v cubed dv equal to 0. So that is what we are going to have, and that is why we have this here. So the x over x minus v cubed dv equal to 0. Okay, now the solution to a homogeneous equation is to integrate through. Okay, so that's why we have integral of the x over x minus integral of v cubed dv equal to constant. That is how to go about it. So the integral of the x over x, like we know, is ln x. The minus integral of v cube is v4 over 4. That means v raised to power 3 plus 1 over 3 plus 1, which means v raised to power 4 over 4, then equal to c. That's exactly what we have here. And so at this point, we can substitute our value for v. Remember, we said that v is y over x raised to power 4. So that's exactly what we have. You can say ln x minus your v is y over x all raised to power 4 divided by 4 equal to c, which is the same thing as saying ln x minus 1 over 4 as a fraction. Then you have your y over x raised to power 4 equal to c. Okay, so that's using the homogeneous method. Now, the next method we are going to use is the exact equation method. The homogeneous method can be converted into an exact method, of course, by method of integrating factor. Okay, so this is what our equation here, our differential equation here, we can make here to be m and make here to be n. Remember, an exact equation must be written as m dx plus n dy, okay, equal to 0. So if we follow this now, you see that the m over dy, that means your m is x raised to power 4 over y raised to power 4. So partial derivative of m with respect to y is 4y cubed. 4y cubed because when you differentiate x raised to power 4 with respect to y, it is 0, is a constant. That's partial derivative. Then when you differentiate y raised to power 4, that's how we got 4y cubed. In the same way, dn over dx, differentiate n, this is n, which is minus xy cubed. With respect to x, it means you are going to get just y cubed, because when you differentiate x, it's going to give you minus 1 then y cubed. Remember, whenever you are differentiating with respect to x, y is constant. Whenever you're differentiating with respect to y, x is constant. Okay, so that gives us minus y cubed. So, and we can see that in this case here, we can start by subtracting the m dy minus the n dx, okay, and that gives us 4y cubed minus y cubed, okay, and that is equal to 5y cubed. Now we observe that when we divide this 5y cubed by n is minus xy cubed. Okay, what do we have? We have minus 5. We get minus 5 over x, which is a function of x. We get minus 5 over x, which is a function of x. And whenever the m over dy minus the n over dx all over n is a function of x, then we can say that our integrating factor from our last video is exponential integral of f of x. Okay, so if we substitute the value for f of x, which is minus 5 over x, like we have here, that is going to give us exponential integral of 5 over x is 5 ln x. So we got exponential minus 5 ln x, and exponential minus 5 ln x can also be written as exponential ln x raised to power minus 5. Okay, so that makes this cancels out, and our value is 1 over x raised to power 5. So that's how we have this. So 1 over x raised to power 5 is an integrating factor. So that makes our original equation, which is supposed to be this. We multiply through by the integrating factor. Remember, the purpose of integrating factor is to convert the given equation to what we want. In this case now, exact. Okay, so if you multiply x raised to power 4 by 1 over x raised to power 5, you're going to get x4 over x5, which is x raised to power minus 1, which is exactly what we got here. Then the same way, when you have y raised to power 4 over x raised to power 5, in this case you get y raised to power 4 then x raised to power minus 5, which is exactly what we get here. Then when you multiply xy cube by y by x raised to power 5, you are going to get xy cube multiplied by 1 over x raised to power 5. You are going to get y cube over x4, as this cancels this. Okay, so that gives us x raised to power minus 4y cube. That's how we got this. So multiplying through by that integrating factor gives us this. Multiply 0 by anything, you still get 0. Okay, so here we continue from here. Let's see if we achieved our purpose. Differentiating derivative of m, partial derivative of m with respect to y here. If you differentiate this with respect to y is 0 because it's a constant. So and derivative of a constant is 0. Now, but when you differentiate this with respect to y, you get 4x raised to power minus 5y cube. In the same way, if I pick these two and differentiate with respect to x, that's the n dx. You know, these are m and these are n. Okay, so if I differentiate with respect to x, remember what we have is minus x raised to power minus 4y cube. Differentiating with respect to x means minus 4 comes down here to become 4x raised to power minus 5, then y cube. That's exactly what we have here. So you can see that these both look alike, meaning that it is now an exact equation. So we can now solve this, where we say let u be equal to partial derivative of u du dx plus du dy, and which is equal to m dx plus n dy, where u is the solution. So in that case now you can see that we can equate du dx to be m and equate du dy to be n. Okay, so now we continue with du dx. Du dx is x raised to power minus 1 plus x raised to power minus 5 y raised to power 4, and we can make u the subject of formula. Remember, the whole of this is equal to m. That's our m. Du dx is m. Okay, so making u subject of formula means the integral of x raised to power minus 1 plus x raised to power minus 5 y raised to power 4 dx, meaning that we are integrating with respect to x. Okay, and integrating x raised to power minus 1 means integrating 1 over x is the same thing, and integrating 1 over x dx is equal to ln x. That's how we got this. Then here, how do we integrate this with respect to x? We are going to get integral of x raised to power minus 5 y raised to power 4 is the same thing as saying x raised to power minus 5 plus 1 all over minus 5 plus 1, but y raised to power 4 is there. Remember, we are integrating with respect to x. So that's going to give us x raised to power minus 4 all over minus 4, then y raised to power 4. That's exactly how we got this. Then whenever you are integrating with respect to x, your integration constant is a function of y. Okay, so that means your u now is equal to this, the whole of this. Now we now find partial derivative of u with respect to y. Differentiating ln x with respect to y is 0, is a constant. Then differentiating this now with respect to y will give me 4 x raised to power minus 4, then y raised to power 3. Okay, everything divided by minus 4. Of course, you see 4 cancels 4, and we are left with minus x raised to power minus 4, then y raised to power 3, which is exactly what we got here. Then derivative of function of y, ty, means t prime y. And remember, the whole of this is equal to n. You know, du dy is n, which is this value here. So what we notice here is that this value cancels this value when you take it to the other side of the equation, and we are going to be left with t prime y equal to 0. And if t prime y is equal to 0, it means that ty is going to be equal to integral of 0, which is just simply a constant. Okay, it is equal to a constant. And remember, u being our solution is equal to ln x plus x raised to power minus 4 y raised to power 4 over minus 4 plus ty now becomes u equal to ln x plus x raised to power minus 4 y raised to power minus 4, then c, which if we rewrite is going to give us ln x plus this is already minus 1 over 4 into y over x raised to power 4 plus c, okay, which is exactly what we got in the previous equation. Mathematics is beautiful. Please, you can do well to click on the subscribe button to get more of our lectures online, notification for our classes online. Thank you very much. Have a nice day.